Good morning. Hello, guys. Good morning for students, teachers, and other people. And this morning, I talk about four important topics to engineering mechanical, vector mechanical of engineering, and other hand statics. Chapter number 4, equilibrium of rigid values. Next. Next. What is the content? Vector mechanical of engineering statics is to have a sober content because it's important material, it's important topic because you graduate whatever career for mechanical engineer, electrical engineer, petroleum engineer, you need to this material because it's important. The analysis and the summary because the content is introduction, full body diagrams, reaction and support connection for the two-dimensional structure, equilibrium for a rigid body in the two-dimension, a statically determined reaction, sample problem 4.1, sample problem 4.2, sample problem 4.3, equilibrium of a two-force body, equilibrium of a two-force body, sample problem 4.4, equilibrium region body in the three-dimension, reaction and support connection for the three-dimensional structure is very important, and the sample problem 4.5. The next is the introduction. For a rigid body is a static equilibrium. The external forcing at the moment is balancing with a vertical part, no translation on the rotational motion to the body. The necessary and sufficient condition for the equilibrium, static equilibrium for a body, are the result force and the couple from the external force for an existing equilibrium to zero. Summatory in the force is equal to zero. Summatory moment in the point is equal. Summatory for the distance is important for the distance and produce for the force. Is equal zero. Resolving each force at the moment into a rectangular problem. They have a six-scalar equation with express the condition for static equilibrium. This equation, this topic is very important for the static. Summatory, vectorial summatory, force in x is equal to zero. Summatory moment in x is equal to zero. Summatory force in the way is equal to zero. Summatory moment in the dimension j, in dimension weight is equal to zero. Summatory force in z is equal to zero. This is equation you can determine where various system is in static problems. The next, for example, full body diagrams in Spanish, diagrama de cuerpo libre. Free body diagram is very important because if you're not really say you're the man, if you don't make the free body diagram, you can serious problem to solve the whatever problem for staff. Is the law. It's very important to remember for dear students this concept, free body diagrams. First, in the static equilibrium analysis of a rigid body is identification for a force acting in the body with a free body diagram. Select the extent of the free body under the train of from ground in the lower of the body. Indicate point of application magnitude and direction of external force, including a rigid body weight. Indicate point application and the summary direction and no application force. This is usually consist in the direction of growth, which is the ground and other body opposite possible motion of the rigid body. Include the measures necessary computing and the moment of the force. You can check, let me see, check the figure or the picture. You can to support 2 points, letter A, letter B. It's very important. Letter A, letter B. Letter A, you have two reaction force. force letter A, force in action, and force letter A in way. It's two dimension. And in letter B is only reaction. The force only reaction in letter B is 1 point. No two reaction, only reaction. The cranes, the cranes is a hard, very large, are to have our own weight, only weight, excuse me, in the structure mechanical, I suppose, was the 2,400 kilograms. Field stand static equilibrium analysis for the ridge, but it's identification for our force, actually in the body, where free body diameter. Other saying the special words, free body diagrams. Select the extent on the free body and the direction from the ground, the other bodies, indicate points, application, magnitude, direction for the standard force, including the rigid body weight. Dear students, it's important because in the R, in the crane, the reaction in letter B, a force A way, force A X. At this point, only reaction letter B, reaction point B. And this moment is important because it's the server weight is the most important force because this point is the determinant for static problem because don't have moment, indicate point application, assuming direction and no applicable force. This usually consists of the reaction, draw, which, and grow, and other bodies. Opposite possible motion for the rich body, including dimension. You can see for diagram, for the picture, is a free body diagram. Reaction in letter E, reaction in letter B is the way above the structure crank, is the way above the mass, 2,400 kilograms. It's not force kilonewtons. Next, the graph is very clear, is very important. It's 500% solve the problems. It's several importance. Next. Next. Reaction the support the connection the two-dimensional structure. It's also important also. For example, the rolling is the large contact with the pavement, with the floor. The floor is 1, 2, 3 points with the contact with the mechanical structure. In this case, in only point with the pavement and the mechanical structure. And this is the area is more large, very few. And in this case, it's very important because between frictionless surface, it depends of the pavement of the mass. It depends of the flow, In this case, you can represent the force when an only point reaction, force with an line of reaction. In this case, you need two cable. For example, short cable, short link. The cable link is a pure force with a no line in the action. Represent when the force is a vectorial. It's a vector that represent is this feature. The color frictional rods and the frictionality pin of a slip is represent for a particular condition because in these mechanical things you can mold for the structure still. Yes, move. It's move. But in this phase or this type, you can check this particular method if condition zero is a static material, is a mode. Check next. Reaction as support and connection for the two-dimensional structure. You can review stationary spin of inch and raw surface. It's important because you can represent in the same meaning. Example. And this reaction in this point you can represent for the figure, for the elements where you have an angle. Angle alpha. Alpha angle is a vector diagram. In this case, the same force you can combine with the combines. Excuse me, with the combine with the reaction in the components. For example, component letter Y, component letter X. Reaction equivalent force and no duration on demand. For example, fixed support. In this case, the mechanical structure is very static. It's not moving for whatever problems in the world. But in this case, you can say represent for figure vector, and you plus a moment on the moment figures. In this case, you are convinced with the reaction, the letter with the vector, it become with the components, and the component letter Y and components letter X plus the moment figures, reaction equivalent to the force and no direction of the magnitude and the computer of unknown magnitude. Next. For example, check it out. The next figure is in Thurston progress in standard exercise. You need to check it out the mechanical structure for what is 100. Excuse me. What numbers? What is the number? Elements. What is element number in this case? For example, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. It's same. It's true. 1, 2, 3, 4, 5, 6, 7, 8. 8 elements. Mechanical structure. Equilibrium of a rigid body in the 2 dimensions. Polar force and the moment acting in the 2-dimensional structure. Summatory forcing letter F is equal 0. Summatory moment X, saying the summatory the moment Y is equal 0. Summatory moment letter X is equal. The summatory moment 0. Equation of equilibrium becomes summatory the force in letter X is equal 0. Summatory the force in letter Y is equal 0. Summatory moment in letter A is equal 0. Where A is at any point in a plane of the structure. So continue. The two equations can be solved for no more than 2 unknown. Why no more than 2 unknown? This number equation is the same for a number they are not variables. I occur in the minimum here. Check it out. This structure is the same. It's the same as this picture. Yes, it's the same. But what is the difference? The difference is in this page. Excuse me. Is free body diagrams. Free body diagram. It's the difference. Free body diagrams. Okay. Free body diagrams. Check it out. these free variables. For example, reaction, letter C. Letter C, you can check the letter C, the force uh, in letter way, and look at the force in letter C in dimension X. And this point, el force Q in the component Y, Q in component X. And that's the other letter in the S, the point S and point D. X in the component Y, X in the component X. What is the difference? Is there are difference. Whatever points you can analyze in a study, you can review the condition. What is condition? The next, excuse me, and the other presentation. This condition is the roller, is the rocker, or in the frictional forcing, in the short ring, or in the short cable. This is condition. This picture depends your reaction or your force. Is it two coordinates or one component on the reaction or two reaction? It depends. Check it out. Follow. Next. Two components. In this Q, in letter Q, two components. In letter D, two components. In the structure, in letter between A, B, in this structure, only one reaction because it's not identified for the picture, figure, or condition that you can review for other diapositives. Yes, another figure. Only reaction is no more. In letter B, you can check force in letter B, reaction, only reaction. In letter A, you can check two reactions. Letter B, component way and component X, because it's a condition that we were followed. The three condition cannot be outlined with addition equation. Is basic, is very important. But remember, always this condition, dear students, to have in this picture, in this presentation, a lot of figure you can practice. In this picture, you can practice free body, Jones, important, for example, can I follow with me? Come. And this thing, force letter P, force letter Q, force letter S, force letter P, force letter Q, force letter S, force letter P, force letter Q, force letter D, force. What is the difference in force? It's there aren't difference, it's the same. It's no problem. I check it out. This is the same. Is the same. What is the difference? You can whatever student participation, and letter A is two reaction because it's two condition. And letter B is two reaction, two condition. And letter A is one reaction. Why? Because it supports, is contact with a point. A point. Letter B, whatever. How many conditions? It's two conditions. Let it be. The figure, check the figure. Let it be two conditions. In this picture, letter A, two conditions. But excuse me, letter A, one condition, one reaction. And letter E, one condition, one reaction. And letter B, one condition, one reaction. It's no more. For example, force P is developed in component, transformed, become P sub Y, P sub X, And letter Q, Q X is similar with the picture number 1, picture number 2, picture number 3. It's the same. Only difference between the reaction in the figure 6 and the figure after in the figure in the other diapositive represents. It's a difference between reaction, different two reaction, one reaction, no more. It's a different. Check it out, reviews. More unknowns than equation. Yes, they have a good reason. Figure unknown than equation partial constraining. This is true. An equal number in unknowns and an equation. It's the same. It's the same. It's the same for the unknown. Is the same with the equation. Let's next. Next. The reviews. In this month, sample problem 4.1. And this string is a similar problem below solve the problems. A piece of crane is a mass 2,000 kilograms. Is a UCV and 2,400 price. And here in place by a pin at A, very big. The center of gravity of the crane is located at B. Determining a company operation at A and B. Solution. What is the solution? So remember, free-body diameter is the most important. Is the first step. Create a free-body diameter for the cranes. Determine a B for the solving equation for the sum of the moment of all forces above A. Now there will be a contribution from the unknown relation at A. Determine the relation at A by solving the equation for the sum of all horizontal force components and vertical force components. Check. Check values obtained for the reaction by verifying the sum of the moment above B of the force is 0. Check. It's 0. Y is 0 for the reaction. In this picture, in letter E, reaction, letter I sub A, letter I sub X, and in point B, only reaction, the force B, only reaction, not only point contacts. The most important charge is a 23.5 kilonewtons. It's the way, it's a structural mechanical way. Share, distribute, share, and they concentrate in this point with the X, and in the Y letter here. It's the straight way, and the concentrate check is in this point, in this direction. Yeah, that's very good. It's 2 meters. The letter B, 2, a letter in the chairs is 6 meters. Follow me. Determine B by solving the equation for the sum of the moment of all forces above A. Summatory moment, letter Y, is equal 0 plus B with 1.5 meters less 9.81 kilonewtons per 2 meters less 23.5 kilonewtons per 6 meters, equal 0. The resource reaction B is 107.1 kilonewtons. Determine the reaction A by solving for the equal for the sum of the horizontal forces and all vertical forces. Summatory forces in X equals 0. Summatory of, in the equation, AX plus letter B, force, if you want, 0, and reaction in X, reaction X is equal negative 107.1 kilonewtons. Summatory force J was 0, summatory force in letter Y was equal 0. And as way less 9.81 kilonewtons less 203.5 kilonewtons equal 0. As way is equal 33.3 kilonewtons. Check the values and change. Check it out. Review the next class. It's a class today. The next class you can analyze these figures. It's a problem. It's a problem 4.2. If you're a student, you can check it out for the figure, figure out the exercise, and that's what I mean the four questions. What is the free body diagrams? This moment is the cable. No, is the maze, is the way concentrate charge in the force in this direction and two welds reaction. There are friction or there are friction. What is the answer? There are or there are friction. Excuse me. That's what I mean for numbers on the maze, please equation. Thank you in the page. The distance 25 inch. The concentrate point in the pavement on the surface and 30 inch G point. The diagrams, the cable, the way, and the contact, the two welds, friction and the friction, and the concentrate charge. This is the force what we intervene in this promise. Next, formula this. Yes, tension, the cable, letter T, reaction the welds, letter R1, reaction 2 welds, reaction 2, letter R2. The distance with the reaction 1, reaction 2 is 50 inch. It's 50 inch. Remember and check it out with an arrow in the book. Concentrate charge. This is inner force, no. This is the yes. This is component the force. This component force you can summatory where direction in letter X, summatory components force in letter Y. Letter Y, letter X. It's simple. It's not simple. You can check in the plane when you have 50 grades, 20 grades, 25 grades, and 40 grades, 45 grades. The force and several chain with the plane is in the grade, and you incline your planes. It's very curious. Clearly, is a recommendation to create a free body diagram. Summatory. Check it out. Check it out. Yes. A loading car is a race on an inclined track. Yes, inclined tracks, angle. The gross weight of the car and the inner loss is a 5 tons, 500 pounds. And is applied at the G. The car is 100 position by the cable. Determine the tension in the cable and the direction and each pair of wheel. Solution. Solution 500% is the free body diagram. This is the second. Some more. Solution. Create a free body diagrams for the car with the coordinate system aligned with the track. Determine the direction of the wheel by the solving equation for the sun and the moments about the point above of axis. Determine for the cable tension by the solving the equation for the sum of the force component in the parallel to the track. For the track. What is the meaning of the track? It is varies the track. Is similar of the car of Tesla Motors, Tesla car. It's not, it's only track. It's not track. Check the values and the thing, verify that the sum of the force in the component perpendicular to the track at zero. It is a zero because what is the solution? The solution is the summatory force in X, summatory force in Y, and summatory moment X and summatory moment Y, and free body diagrams is the step by step. Next, this is the free body diagrams. Create a free body diagram is presentation is picture and summatory W in the punch in letter X is equal 2,200 libras pounds and per cosine 25 grades. This answer is equal 4,980 pounds. Yes. Summatory point, summatory way and y. Difficult. Less the signal to negative. 5,500 points plus sin 25 grades. The answer is negative. Why is negative is not positive? The negative supports or meaning the weight is different, it's opposite. It's opposite, yes. In the positive direction, the same. Direction the same. Yes, direction the same. Direction the same. When it's negative, the direction is opposite. Opposite, yes. Check it out. Opposite, it's opposite, it's opposite. It's negative, it's positive. Positive, yes, it's positive. It's positive. It's a negative force. It's negative thing. It's negative force. It's negative force. It's positive force. It's positive force. The same direction, no opposite. The negative. The negative in the plane way, yes, negative, opposite. Positive, the same direction. Representatives. Another step, determine the duration of the words. Summatory moment in letter B is equal to 0 Leather negatives, 2,220 pounds per 20, 20 in, less negative, summatory negative, 4,980 pounds per 6 inch. Last, reaction number 2 is this. The reaction number 2 is the variable, is incoming. Reaction number 2 is the solution. Purge parts 50 inch is equal 0. The reaction 2 is equal 1,017 is 1,758 pounds. Summatory moment in letter B is equal 0 plus 2,320 pounds per 25 inch. Negative sign negative and 4,980 pounds per 6 inch. 6 inch. Negative reaction number 1. Reaction number 1 is the other words. This is the reaction is incoming. It's the variable you can find in this program on the short the exercise. Yes, negative reaction 1 per 15 inch is equal 0. The answer reaction number 1 is equal 562 pounds. Determine the table picture. So the reaction, the table picture, you can summatory the force, no summatory force in letter X is equal to 0. The exercise, see, positive is 4,980 pounds. Negative letter T, or tension the cable is equal to 0. This the answer was the tension letter T is equal, letter T is equal positive 4,980 pounds. Thank you very much for this introduction class. In the next class, you can resolve more exercise. Thank you very much, students, teacher, and ladies and gentlemen. Thank you very much. Good afternoon. Yes.